When I was first learning Node.js, I had some code similar to this, and I wanted to answer a fundamental question. How do I get Node to wait for future time to be resolved before I log the next line? If I run this code here, you can see that the time in the future is undefined, and then we get, I finished getting the future time. But if we have a look here, future time is the result of get future time, and get future time has a set timeout, and after 1 second, it's going to return a new date, but instead we're getting undefined. So how do we wait for Node.js to run the set timeout and return our result? Well, the answer is a callback. And a callback is simply a function that you pass into another function that will get executed when you call that function. So let's define our callback here. So I'm going to say function callback, and then I'm going to move our two console logs into the callback function. And our callback function is going to be called with future time. Now I can pass this callback function into get future time. I can remove this constant here. And we need to modify get future time to execute our callback function. So I can pass callback in as an argument, and then I can execute callback with our new date. So now let's run our code again. And you can see that we wait for a second, and then the time in the future is returned with this time in the future. And then we log, I finished getting the time for the future. And this code looks fine. And we went about using this code for a long time, but a problem arose when we needed to use future time in another variable. Let's create another function here. Function add some seconds. And we're going to take time. And we're going to call another set timeout. And we're just going to return time.getTime plus new date dot get time. So let's call add some seconds. So inside of our callback function, I'm going to execute add some seconds. And we know that we need to wait for our set timeout to execute. So we need to pass a callback function into get some seconds. Here's a console.log. The result of add some seconds is, and our callback is going to get called with an argument. So we're going to say new date, and then we're going to pass in new date. So add some seconds also needs to get called with future date. And you can see here now we have two arguments being passed into add some seconds. So let's define our second argument. So I'm just going to call this callback. Now we're going to execute our callback. Now we're going to execute our callback with our new calculated time. Let's run this code. And you can see that it worked perfectly. But you can see this little arrow forming here, and this is what we call callback hell. So let's fast forward a couple of years where we try to fix this problem with promises. So to define a promise, we need to use the promise constructor. So I'm going to say const I promise equals new promise. And a promise takes something that might look familiar now, a callback. And a callback is called with two arguments. The first argument is resolve, and the second argument is reject. And resolve and reject are both functions. So if your promise is going to resolve, you're going to call resolve. And if your promise is going to throw an error, you're going to call reject. And this is called a promise because we promise to either resolve or reject. There's no in-between ground. And this makes promises really reliable. Let's say const num equals math.random. And we're going to say if num is greater than 0.5, then we're just going to resolve with our num. And I'm going to return. And then if the number is less than 0.5, I'm going to return reject. And I'm going to reject with an error that says the number is too small. So how do we use our promise? Well, we create a function. And then we call iPromise.then. And .then is going to get called if the promise resolves. And if the promise doesn't resolve, then .catch is going to be called. And this is where you would handle your errors. And inside a .catch, we're going to get an error argument. So I'm going to console.error, our error. Otherwise, I'm just going to console.log our num. And num is going to come in the first argument of the .then callback. So now we just need to execute our run function. And we can run our script. So you can see here, it gets logged, the number is too small, so we must have hit our catch here. We can run it again, and if the number is above 0.05, which 0.78 is, then it's going to log out the number. If you need to pass some arguments into iPromise, then you can see iPromise here is just going to return a promise, but we can make iPromise return a function that returns a promise. So you can see now we have a function that returns a promise, and we can have our arguments here. When we execute iPromise, we just need to execute it as we would execute a function, and then we call .then. So you can see we get the same result here. If you want to run a piece of code, no matter whether we reject or resolve, you can call .finally. And .finally is going to get executed no matter which one of these is called .then or .promise. So we can say console.log finally was called. So you can see our number resolved and we called finally. You can see our .catch was called and finally was also called. Let's fast forward a couple of years and decide that we don't like constructors anymore. Instead, we just want to create promises with functions. So let's remove our promise constructor here. So iPromise no longer returns a promise, and we don't have these resolve keywords or our reject keyword. So let's instead return our number. And instead of rejecting, we're just going to throw an error. And to make iPromise return a promise, we need to use the async keyword. So you can see now that iPromise is going to return a promise. So let's run this code. And you can see that it runs exactly the same as it did when we were using the promise constructor. So let's fast forward a couple more years and decide that we now don't like this .then and .catch and .finally syntax. Instead, we want to use try catch, and we want to use the await keyword. So now we're getting into what is called Async-Await. So now let's define a property called num, and we're going to make this equal to iPromise, and we're going to execute iPromise. And we're just going to console.log num. Let's execute our async-await code. And you can see here we get an unhandled promise rejection warning. And this is something that we really want to avoid because this will cause all sorts of problems within our application. So let's try to fix that with try. And we're going to catch the error. And we're just going to console.error e. Now let's try this again. And you can see we get this promise object here, and our promise object contains a number, which looks correct, but it shouldn't have this promise object here. So let's fix that with our await keyword. Let's try run this code again. And you can see await is only valid in an async function. Okay, so we need to make our run function an async function using the async keyword. And you can see now we don't get an unhandled promise rejection, and we just get our error logged to the console. So let's run this until our promise resolves successfully. So our promise has resolved successfully, and you can see we get our number, and it's not in a promise object anymore. So let's take a look at how we would use this code in real life. So I'm going to import a package called Axios. And I'm going to use Axios to make a GET request for me. So I'm going to call my function now get character. And I'm going to say const result equals await axios.get. And I'm going to make a GET request to this Rick and Morty API with a character ID. So we need to pass our character ID into the arguments. And then we just want to return result.data. Okay, so let's call our getCharacter function here. And I'm going to call getCharacter with the ID of 1. So you can see that it returns Rick Sanchez, which has a character ID of 1. What happens if we put a character ID in that doesn't exist? You can see we get an error, request failed with status 404. And if we weren't handling this error here, we would get an unhandled rejection warning. So instead of throwing an error, what if we just want to return null if the character ID doesn't exist? Well, we can do the same thing up here. We can add a try, and then we can add a catch block, and we can just return null. And we need an error in the catch block. Let's try this again, and you can see our character is just null. So that's how you use Async-Await. And as a thank you for sticking around, I'm going to show you something that is new in Node version 14 that I think you'll find really handy. So you'll notice we've been using this run function and we've been executing it down the bottom here. And this is because run needs to be an async function in order to use the await keyword. If I do nvm ls, you'll notice that I'm using Node version 14. And because I'm using Node version 14, I can change my script from .js to .mjs. And inside a module script with Node version 14, I can use top level await. So I no longer need this run function here. I can use character equals await. And you notice we now have await that isn't wrapped inside an async function. Console.log character. Now we can remove all this code here. And if I run my script, you can see that we get null. And if I change this to a valid character ID, we should get our character back. So that is how to use callbacks, promises, and Async-Await. If you like this video, please make sure you give it a thumbs up and subscribe for more videos. Thank you for watching, and I'll see you in the next one.